welcome back. We're going to your favorite pre-calculus class, of course. We're going to create the unit circle using the right triangle definitions of the trig functions. All right, create the unit circle using the right triangle definitions of the trig functions. All right, there we go. Spit it out. So here we go. Remember, that's x squared plus y squared equals 1, right? X squared plus y squared equals 1. So if you were to go, and we're gonna go, you know how that's 30 degrees, we go to the 45-degree mark, 60-degree mark, and so on, right? We're gonna look at that. So if we rotate, how much did we rotate? We rotated 30 degrees, right? So I have a little 30-degree angle right there, and I'm gonna draw the triangle. So go straight down, okay, straight down there, and make that 90-degree angle. And of course, we know this other angle up here has got to be 60 degrees, right? And now think about this. This is the unit circle, so your radius is 1, right? Not here. No, 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 because that from here to this right triangle spot here, that's not 1. The radius is 1 all the way to the circle, right? So that hypotenuse here is 1. But this helps us because we're like, hey, I got this 30, 60, 90, right? So if I think about this, okay, I have this 30, 60, 90 triangle, and my question is, okay, what would that be? What would that be? And I say, well, let me use my special trig functions, special right triangles, 30, 60, 90, right? So I go 1, hypotenuse 2, root 3. So I say, oh, okay, I can now figure out each side, how far is it that way and how far is it up that other way, okay? So I say, question mark, let me call this A. A, so small is to the big. A is to root 3 as, let's go 1 is to 2. 1 is to 2, and I solve for A. Cross multiply there. So A is root 3 over 2. A is root 3 over 2. Let me put it over here on the root 3 over 2. Okay? And then my B is going to end up being, I'll call this B. Okay? Let me go small is to big. B is to 1 and I'll use my hypotenuse here. 1 is to 2. Okay? So 2b equals 1 if I cross multiply, so b ends up being a half. B ends up being a half. Okay? So now you look over here on this unit circle. Okay? You remember how we defined the cosine? The cosine, we defined that thing to be the x value, right? So I say, well, how far over did I go to get to here, right? For this point right here. How far to the right? I went root 3 over 2, whatever length that is, right? Some number. And then how far up did we go? You know, how far up? How much y? Half, right? Again, this is our cosine. This is a cosine of theta. This is our sine of theta, the y value. Cosine theta dx, sine of theta being the y, okay? And so we use the similar triangles, right, to create that and the definition of the right triangles. And we could do that for the entire unit circle. Let me get a new one here real quick. I'm going to continue on with this. I'll show you how we can get this whole thing. Okay. Now, instead of doing similar right triangles for these, I kind of cheat it a little bit and I say, well, I know that it is a radius of 1, but I'm going to just use my triangles because I know it's 1, to root 3. It has that same ratio. So then I can do this a little quicker. So here's how I like to think about it, is I say the sine of 30 degrees. The sine is opposite sine y value over hypotenuse, all right? 1 over hypotenuse 2, all right? That's my sine, that's my y value. Cosine of 30 degrees is adjacent, cosine, my x value here, over who? Hypotenuse 2, okay? And this can help me. I can do this for each one of these. Okay, now I draw the next spot. Well, my next spot's at 45 degrees. Let me erase this here. Okay, so for 30 degrees, of course, how much is 30 degrees? I say, well, 30 degrees, if I need to figure out, because I need to write this in radians as well. Pi over 180, multiply, there's pi radians, pi amount for every 180 degrees, right? A half a revolution there. Pi sixth, pi sixth or 30 degrees, right? Okay, so let's go to 45 degrees. 45 degrees. Erase this here. Okay, so now I'm going 45-degree rotation, all right? And I would do the same thing with similar triangles, but again, I'm going to kind of cheat it. 1, 1, root 2, all right? 45, 45, 90. So the cosine of 45 degrees, cosine is adjacent over hypotenuse, 1 over root 2, 1 over root 2, which is, you really ought to rationalize that. Root 2 over 2, right? Isn't 1 over root 2? When I rationalize that, root 2 over 2, you see that? Okay. Okay. And the sine, opposite over adjacent. I'm sorry, opposite over hypotenuse. Opposite over hypotenuse, right? 1 over root 2, which again is, the sine is the y value. Root 2 over 2. So this is 45 degrees, or, again, you go to the side, and you have 45 degrees times 180 over times pi. Oh my goodness. Pi over 180 degrees, and you're like, oh yeah, okay. That's pi fourths, right? Or pi fourths, 45 degrees, or pi fourths. I should have done this bigger. Okay. Now we rotate to the next one. We say, okay, I did the 30 mark, I did the 45-degree mark, now I do the 60-degree mark, and I'm going to draw those, right? Do it in black here. So now I rotate 60 degrees this time, or pi thirds. Same thing, okay? Again, go to the side, multiply 60 by pi over 180, you get the pi thirds there. Okay, but this time you're 30. If this is 60 down here, that central angle, that's got to be 30 up there, right? I'm drawing my right triangle, so I got 30, 60, 90. And I remember, okay, 30, 60, 90. Opposite the 30 side, 1. Hypotenuse 2, root 3. And again, I know that your radius is actually 1 on this, but we already showed you how to solve for that using those similar triangles, right? So I'm kind of cheating this a little bit. So 60 degrees, so I say, well, let's do our cosine. Our cosine is adjacent over hypotenuse, 1/2. Our sine is opposite over hypotenuse, root 3 over 2, okay? Now, do you notice how on the 30-degree mark here, right, at 60 degrees, see how they're just flip-flop there, your x and y are anyways? Okay. Oh, and of course I should have said if I don't rotate at all, so 0 degrees or 0 radians, I'm at the point 1 comma 0. Okay, I got to put those in. 90 degrees 0 comma 1, right? Again, our radius is 1. 180 degrees negative 1 comma 0. Up here, pi halves are 90 degrees, right? This one's at pi or 180 degrees. This one's at 3 pi halves or 270 degrees. And what point is that? 0 comma negative 1, right? And again, we rotate all the way around 2 pi and we get back to that 1 comma 0. Okay, so now we go into, let me stop there. I got somebody in here, drainage systems.